Okay. So it says f of x is an even function if and only if f of negative x is equal to f of x for every value of x. And let's just go ahead. I'll tell you what, we'll come back and look at the odd function definition in a minute. Let's look at what this even function idea means first. So it's an even function if this is true. F of negative x is equal to f of x for all values of x. That sounds kind of technical, but really what it's saying is this. For example, if we have an even function, then if I plug -3 into that function, the y value I get out should be exactly the same as the y value I would get out if I plugged +3 into the function. So if it's an even function, it doesn't matter if you plug a number into the function or if you plug the negative of that number into the function, you get the same answer either way. So let's look at an example, and I think you'll kind of see how this could happen. So here's a function. F of x is equal to 3x to the 4th power minus 5x to the 2nd power plus 7. So if we wanted to check and see if this is an even function, then what we need to do is figure out what f of negative x looks like. So here's what you have to remember. We've been doing this. You just got to learn to generalize it, because where algebra students struggle is they just want to think about numbers. This is some number. I just don't know what the number is. You've got to think in more general terms. So here's what we do know. Whatever I plug into the parentheses here in place of x, in this case I plug negative x in there, then I have to plug negative x in place of x on the right-hand side of this equation as well. Everybody see that? So, like if I had put f of 2, wouldn't y'all just plug 2 in here in place of x? And then try to simplify it, see what that's equal to. Well, I didn't plug 2 in here. I plugged negative x in here. Then I need to look on the other side of that equation, and I need to replace these x's with what I replaced x with here, negative x. So it'll be 3 times negative x to the 4th minus 5 times negative x to the 2nd plus 7. So everybody see what we've done so far? All I did is I replaced the x's with negative x because this is what it told me to do. Here's the thing. If I have, let's say that negative x, let's say that was -3. What is -3 to the 2nd power? +9. Isn't that exactly the same as +3 to the 2nd power? So wouldn't negative x to the 2nd power be exactly the same thing as just x to the 2nd power? Because negative x times negative x is literally positive x squared, right? And wouldn't the same thing happen here with this negative x to the 4th? Like if I had -2 to the 4th power, well, that would be -2 times -2 times -2 times -2. That's -2 to the 4th. But when I multiply all that, won't I get +16? Because -2 times -2 is +4. +4 times -2 is -8. And -8 times -2 is +16. Y'all see that? But isn't that the exact same thing as +2 to the 4th power? So negative x to the 4th power is exactly the same thing as positive x to the 4th power. Y'all agree? So if I were to simplify this, I could say, well, 3 times negative x to the 4th is just 3x to the 4th, right? Minus 5 times negative x to the 2nd is exactly the same thing as just x to the 2nd plus 7. But isn't this our original function, f of x? Y'all see that? That's the original function we started with. So f of negative x, what we've just shown is that f of negative x is exactly equal to f of x. And that's going to be that way for any value of x. Y'all see that? And this is an even function. Everybody with me? And we'll talk about how it might be even simpler to recognize that here in a minute. But let's go back and talk about odd functions right quick. And we'll look at one more example. Then I think we can begin to kind of make a prediction about what's going to happen in general. So let's look at this definition of odd functions. It's almost like the definition of even function. F of x is an odd function if and only if f of negative x is equal to negative f of x for every value of x. Everybody okay there? What happened? Is that Olivia I see coming in?
Yes, sir.
Or is that Stephanie? Olivia? Okay.
Yes.
If they leave, yeah, make sure you just pick up there should be your test and your practice test should be there. All right, I'm gonna get back rolling. So try to remember to hit mute. I think that must be what it was. It's just the shuffling. All right, so odd function. Now remember, in an even function, f of negative x is equal to f of x. But in an odd function, f of negative x is equal to the negative of f of x. So let's take a look at an example and see what that actually means. So what if we have this function? What if this is our f of x? So f of x is equal to 2x to the third power plus 5x. So if we want to know whether this is an even or an odd function, we need to see what f of negative x looks like. So f of negative x is equal to, again, all I'm going to do is replace these x's with negative x. It's equal to 2 times negative x to the third plus 5 times negative x. So we'll talk about the 2 times negative x to the third power in a minute, but do you agree that if I have positive 5 times negative x, that's just the same as negative 5x? Because positive times negative is just negative, right? Just like if I had positive 5 times negative 2, wouldn't that be the same thing as negative 5 times positive 2, which is negative 10, right? Then here, I've got negative x to the third power. So let's see what happens when we saw what happened when we raise something to the second power or the fourth power. Let's see what happens if we raise something to the third power. What if I had negative 2 to the third power? So negative 2 to the third power would be negative 2 times negative 2 times negative 2. And of course, that's going to be negative 8, right? Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Isn't that the same as the negative of 2 to the third power? 2 to the third power is 8. The negative of that is negative 8. Do y'all agree? So negative x to the point I'm making is, when we had negative x to the fourth power, that turned out to be positive, right? Because you were multiplying a negative times itself 4 times, an even number of times. But this is really going to be negative, right? So negative 8 is the same as, for instance, negative 1 times 8. Well, then this 2, let me come down here. This 2 times negative x to the third power is the same thing as 2 times negative 1 times x to the third power. But look, that's just negative 2 times x to the third. Do y'all see? So the point is 2 times negative x to the third is the same thing as negative 2 times x to the third. Everybody see that? Now I'm going to do something here. Y'all should be able to see what I've done. I've got, so f of negative x is equal to negative 2x to the third minus 5x. But could I do this? Could I say that that is equal to the negative of, in parentheses, 2x to the third plus 5x? Couldn't I just factor that negative out? All it would do is reverse these signs, and that would be exactly what we have. But inside the parentheses here, look, I've got our original function f of x. So that is the negative of f of x. So for this particular function, f of negative x turned out to be the negative of f of x, which means that this function is an odd function, right? So, okay, let's look at these two examples if I hadn't marked over that other one so bad we can't read it. So here's an odd function. Here's an even function. So this is an even function. This one's an odd function. I think if you look at this a minute, you could make a guess about what it is that makes this be an even function and what it is that makes this one be an odd function. What is it? It's the exponents, exactly. Notice how in this even function, we only have variables raised to even powers, the second power and the fourth power. In this odd function, we only have variables raised to odd powers. X to the first power, 1's an odd number. X to the third power, 3's an odd number. Everybody see that? Now, the one thing to notice is this even function has this constant term. The constant term's an odd number, but the constant term always contributes toward it being an even function. So in other words, if it's got a constant term, it can't be an odd function. Like if this had been 2x to the third plus 5x plus 2 or plus 3 or whatever, it couldn't be an odd function. Because remember, for it to be an odd function, when you replace x with negative x, it's got to reverse all these signs. But if I had put a constant out here like plus 3, then when I plug negative x in, it would reverse these two signs, but not the sign of the constant term. Y'all see that? So the constant term always counts toward it being an even function. By the way, this might help you remember that. We generally think of constant terms. So this 3x to the fourth is a fourth degree term, right? And negative 5x to the second is a second degree term. We usually think of constant terms as being 0 degree terms. There's actually a reason for that, and I don't want to get into it right now because we're going to see it later in the course. But there's actually a math reason to say that a constant term is a 0 degree term, and 0 is an even number, right? So if there's a constant term, it's always going to count toward it being an even function. And any terms that have variables can only be raised to even powers if it's an even function. And in an odd function, you can't have any constant terms, and all the variables have to be raised to odd powers. Y'all see that? So that means this definition, we don't really have to worry much about it in terms of like if you see on homework and they ask you, is this an even or odd function? Just look and see if all the variable terms are of even degree, then it's an even function, whether it does or doesn't have a constant term. If all the variable terms are of even degree, it's an even function. If all the variable terms are of odd degree and it doesn't have a constant term, it's an odd function. And if you've got any mix of those, it's neither. So if I had something like this, if I had a function like this, I would just have to say that it's neither even or odd, because I've got fourth degree, second degree, and a constant term that counts as a 0 degree. That would make it an even function. But I've also got this one term that's raised where the variable's raised to the third power of odd degree. So it can't be an even function because it's got an odd degreed term. It can't be an odd degreed function because it's got some even degreed terms. It's just neither. Everybody see that? So the thing to know is that this idea of even and odd function, it's kind of like a special case, right? It's like the exception, not the rule. So in other words, when you see a function, don't just expect, oh, I got to figure out it's either even or odd. I mean, it's probably neither, but it might be even or odd depending on whether it only has even degreed terms or only has odd degreed terms. I'm going to go real quickly. I'm going to switch our perspective here, and I'm going to go to Wolfram on the computer so I can show y'all what the graphs of these look like. So you know we were talking about graph symmetry right at the end of class last time. Let me get up to it and then I'll switch over to it. Okay, I'm gonna turn off the document camera and go over to Wolfram, so y'all hang with me a second. There we go. Okay, so I'm gonna put that function in that we tested to see if that turned out to be an even function. So that was f of x equals, where'd it go? 3x to the fourth minus 5x squared plus 7 plus 7. Let me look, make sure that I did that right. Yeah, 3x to the fourth minus 5x squared plus 7. Okay, so remember we talked about y-axis symmetry of graphs last time. So take a look at that graph. It's a kind of a W shape. Does everybody see that that fits the definition of y-axis symmetry? Remember, y-axis symmetry means it's like a mirror image of itself on either side of the y-axis. Everybody see that? Every even function's graph has y-axis symmetry. And any function whose graph has y-axis symmetry is an even function. By the way, there's a question about this on the test, so y'all probably better make sure you remember that fact. So any even function's graph has y-axis symmetry, and any function whose graph has y-axis symmetry is an even function. So let's look at the other one, the odd function. That was 2x to the third plus 5x plus 3. Let's see what that graph looks like. So there's our function. F of x is 2x to the third plus 5x plus 3. That's a terrible picture. Look at the bottom picture. I think it's zoomed in a little better or so you can see it. That is origin symmetry. Remember, origin symmetry is the one that if you spin it upside down, if you look at it, in other words, instead of looking at it right side up, if you look at it upside down, it looks the same. And that one does that. That's origin symmetry. And so it turns out that every odd function's graph has origin symmetry. And any function whose graph has origin symmetry is the graph of an odd function. Everybody with me there? And like I say, that only happens, oh, that one doesn't have origin. What was I thinking there? Why did I put, oh, I didn't erase the plus 3. Oh, it doesn't have origin symmetry because look, it doesn't go through the y-axis right at the x-axis. It actually does it farther back here. You can see that better in this picture. Let me fix that. That one's neither even or odd because it's got a constant term in it that would count toward even degree. Now let me get rid of this, and now we can see for sure it's got origin symmetry. Yeah, now you can see that it actually, you know, it's going, if y'all follow the cursor here, it's curving up, and right there where the x and y axes cross, that's where it starts curving the other direction. And if you were to flip that over, it would look exactly like the one we started with. You know, if I mix something like this in, if I do this, this is the last thing we'll look at here because we got to get rolling again. So now I've got a third degree term and a second degree term, 2x to the third plus 5x squared. And notice we don't see graph symmetry, right? Like that would not be this, if this is not a mirror image of itself on either side of the y-axis, and you can see that if you were to flip it upside down, it would not look the same. This hump would be below the x-axis on the other side of the y-axis, and this dip that actually sort of looks like it hits the x-axis, all of that part of the graph, if I looked at it upside down, would be, instead of above the x-axis, it would be below it. So it doesn't have symmetry. That's because that's not an even or odd function. Okay, back to our document camera. But mainly, again, what you need to know is even functions graphs have y-axis symmetry, or odd function graphs have origin symmetry, and if it's neither, it won't have either one of those kinds of symmetry. Okay, so oh, there we go. So the next little topic that we still need to pick up from 2.2, these next two topics, neither of these things are on the test, but you will see them in homework. I'm gonna go over them very quickly. They're super simple. And the questions in the homework using them are super simple. So I'm going to go over these pretty quickly. One is this idea of piecewise functions. That's P-I-E-C-E-W-I-S-E, piecewise functions. It's a function that is given to you in pieces, right? This particular function is given to us in two pieces. And so what it is, what we're doing is, if our x value, everybody look where I'm pointing here, if our x value is less than or equal to, then we would plug that x value into this top piece of the function to find the y value that goes with it. If we have an x value that's greater than 2, we're going to plug it into this bottom piece of the function. Everybody see that? So we'll just find some functional values here just to make sure everybody sees what's going on. So f of 0. Well, 0 is less than or equal to 2, so I'm supposed to plug it into the top piece of the function. Negative 2 times 0 plus 3, which is 3. F of 1. Well, 1 is also less than or equal to 2, so I plug it into the top piece of the function. Negative 2 times 1 plus 3. And so that's negative 2 plus 3, which is 1. So f of 1 is equal to 1. F of 2, should I plug 2 into the top piece of this function or the bottom piece of the function? Top, because it says if x is less than or equal to 2, I plug it into the top piece, right? Well, 2 is equal to 2, so I need to plug it into the top piece. So negative 2 times 2 plus 3. That's negative 4 plus 3, which is negative 1. So f of 2 is negative 1. F of 3, where should I plug that 3 in? Top or the bottom? The bottom piece, of course, because 3 is greater than 2. So if we want to know f of 3, we're going to have to plug it into this bottom piece where we'll have 3 plus 5, which is 8. Everybody see that? So you wouldn't plug 3 into the top part of the function, because you only use that if your x value is less than or equal to 2. If x is greater than 2, you need to use this bottom piece of the function. Y'all see that? So those are called piecewise functions, and that's really all you need to know about them. Is you have to look over here to see, based on what your x value is, which piece of the function you plug it into to get your value. Y'all see that?
Are you just using any number?
Huh?
Are you just plugging in?
I'm saying whatever number you do plug in, you're going to plug it in up here. If it's a number that's less than or equal to 2, you're going to plug it in down here if it's greater than 2. That's all. I just chose these values because I wanted us to see some that got plugged into the top piece and something that got, and something that got plugged into the bottom piece. I mean, this is our function. We could find any functional value we wanted. But if x was 100, I know I'd want to plug it in down here and get 105. And if x is negative 10, I know I'd want to plug it in up here and get 23, right? Everybody with me there? So that's simple. I think there's a problem or maybe two in homework, and it's, like I say, pretty much just like that problem. Last thing in 2.2 is this idea of the difference quotient. So remember, a difference is, when we say the difference of two numbers, we mean subtraction, right? A quotient is the answer you get when you divide stuff. So this is a difference quotient. And if you look at this weird looking expression here, y'all look, you see that on top I'm subtracting, that's a difference. And you see that this whole thing I'm dividing by h, and that answer would be a quotient. So this is usually called the difference quotient. The difference quotient of f of x is, it's equal to f of x plus h minus f of x all over h. Now, I know what everybody's thinking. I think I do. I feel like a mind reader. I think I know what you're thinking. Like, what's h? What's x plus h, etc. Here's the thing. If there was not a homework problem assigned here, I wouldn't even talk about this. We're never going to use this in this class other than to do this problem. But for any of you who have to take calculus, you will see this again. In fact, on the board here in our Greenville classroom, this side board where somebody keeps leaving a bunch of math on it, we actually saw examples of this being actually used earlier this semester. I'm sure y'all don't remember seeing that, but it was up on the board because their Calculus 1 class was going over that. I'm just going to show you how to do it. First of all, the thing to remember is it doesn't matter what h is. H is some number. All I know is if I do exactly what I'm told, you can see the trickiest part of this. We know what f of x is. It's given to us, 4x minus 9. I don't know what h is, but it's just h. It's some number. Could be any number. Probably what would be confusing here is this f of x plus h part. Y'all agree? Like, that's the part that looks worst. So let's look at that first. Let's figure out what f of x plus h is equal to. Well, here's my function f of x. It's equal to 4x minus 9. So f of x plus h, what's that telling me I should do? What if this said, y'all listen, what if this said f of 3? What would I do here? Wouldn't I just plug 3 in place of x? Then why do y'all not keep being confused about the fact that if instead of a 3 being here, there's an x plus h here, that I would still just plug that x plus h in place of x? Like, what's the difference if I write the number 3 here, or if I write, trying to think what I could write that's not, if I wrote yes, the word yes here, then wouldn't I just replace this x with yes? If I put a little picture of a cow here, wouldn't I replace this x with a little picture of a cow? The point I'm making is when you have a function f of x, it does not matter what you replace x with here. In this case, we replaced it with x plus h. You're going to replace x with that exact same thing on the other side as well. So that's f of x plus h. It's 4 times, in parentheses, x plus h minus 9. Now, I can simplify that. I should distribute that 4, right? 4 times x is 4x. And 4 times positive h is positive 4h. And don't forget, we've got a minus 9 out here. So that is f of x plus h. Do y'all see how we found it? It's not difficult. It's super easy. You just replace the x in this function with x plus h. And when you do whatever you can do to simplify it. In this case, we could distribute the 4 and get rid of those parentheses at least, right? So there's our f of x plus h. There's f of x plus h. Here's f of x. That's our original function f of x. So what is this difference quotient? Well, it's f of x plus h. That's 4x plus 4h minus 9, right? We just learned that. So that's the f of x plus h part of this. Minus f of x. Well, f of x is 4x minus 9. And that's all over h. Again, I don't know what h is. It's there. I'm just going to keep it there. Now, I have made a mistake here. If I don't fix it, I'm going to miss this problem. Does anybody see what the mistake is I've made? You got to probably look pretty close to figure it out. So notice that here, that's the f of x plus h part, right? What comes after this minus sign, that's the minus sign that's here. What comes after that is f of x, which is 4x minus 9. But what's wrong with that? Yeah, that minus 9, she said maybe that should be in parentheses. Yeah, it probably should, because I'm supposed to not just subtract 4x, I'm also supposed to subtract negative 9. Wouldn't that really mean the same as adding 9? So look, to be on the safe side, just do this. There's f of x plus h. Here's f of x. I put parentheses around it, put a minus sign between them. Because now you can see that if I want to simplify this, I've got 4x plus 4h minus 9. But notice I'm supposed to subtract all of that function. That would be negative. Negative times positive is negative, so that would be minus 4x. But notice it's not going to be minus 9. Do y'all see that? Because the negative of negative 9 is positive 9, right? All over h. By the way, here's really how to think of this. When you see minus f of x, that means the negative of f of x, kind of like what we talked about when we talked about the odd functions. So really what it means is, y'all look where I'm pointing here. When you write this down, you write down your f of x plus h just like it is. But then when you write down the f of x part, because you're subtracting or negating f of x, notice every sign of every term in the function f of x reverses. See, it was positive 4x, but if you're going to subtract, it should be negative 4x. It was negative 9, but if you're going to subtract negative 9, it should be positive 9. So I think calculus students at some point, they just start going, oh, when I see the minus f of x part, it just means reverse the signs in f of x. At any rate, once we do this, let's see if there's anything we can do to simplify it. First of all, I see 4x minus 4x. Y'all see that? I could just cancel those, can I? What else could I cancel? I got negative 9 plus 9. That's 0. That cancels. So all I have is 4h over h. What's that equal to? Won't the h's just cancel? H over h is 1. 4 times 1 is just 4. And that's our answer. So now, because I guess the question is, what have we done? And it kills me to say that I can't tell you exactly what we've done, because you need calculus to know what we've done. But I mean, I can tell you, it just might not make a lot of sense to you. But it turns out that this function f of x equals 4x minus 9, what is called the derivative of that function is just the number 4, you know, which means nothing to you if you never had a calculus class. They put this in here because they know that some students who take college algebra will ultimately take calculus. And so it's good to have seen this difference quotient at least, because you use this idea a ton in calculus calculus is really divided up into two parts. There's derivative calculus and integral calculus. And this little expression here is actually the gateway to all of derivative calculus. So, you know, that's why they put it in here. But all y'all need to know, and you're only going to ever be asked to do this, even in the homework, with linear functions like this, you know, something like, you know, f of x equals whatever, 3x plus 7 or something like that. So it all works about the same. And you see that if you do it right, and if you remember to reverse the signs when you do that minus f of x, if you've done it right, everything should cancel on top except for anything that's got h in it. And of course, anything that's got h in it is going to cancel with that h on the bottom. Everybody see that? And that happens every single time. So that's the difference quotient. Again, you're not, that's not on the test, but I think you're going to see a homework problem over it. Okay, so I'm going to call that done, and we've got to move on. So section 2.3. Section 2.3, we talk about equations of lines, and we're going to start by talking about the slope of a line. And we're going to try to get through the slope discussion by break, and then we'll come back and talk about equations of lines after the break. So the slope of a line, I should have covered some of this up. Some of you have probably been taught this. How many of you have seen that before? Slope equals rise over run. Okay, so slope of a line, first of all, slope, the slope of a line is a number. And it's a number that in some way is exactly measuring the steepness of the line, or sort of how fast, at what rate that line is growing, how steep it is. And we're taught that slope is rise over run, which is fine. There's nothing particularly wrong with that. I don't like it, though. I prefer to use this. By the way, I guess the first thing I should talk about before I start talking about all this notation is just the fact that we use the letter M, a lowercase italicized letter M, to represent slope. And there is no letter M in the word slope. I get that. Like, maybe S would be a better letter to use to represent slope. But we use M. As I told my Monday class, some mathematicians argue that M is the first letter of the word slope in French. So the guy who came up with the idea of slope was the French mathematician René Descartes back in the early 1600s. And so there are mathematicians who argue that M is the first letter of the word slope in French, but I don't even think that's true. I don't know why we use the letter M, but we do. We always do. And so this is like a triangle, Y over triangle X. That triangle is the Greek letter capital delta. And it actually corresponds to our capital D. So our alphabet is stolen pretty much straight from the Greek alphabet. I mean, literally, the first letter of the Greek alphabet is alpha, and that's capital alpha. And this is lowercase alpha. And you may not see our lowercase letter a in that, but it's in it. Because if you think about how you see lowercase a typewritten sometimes, something like that, that's taken from the lowercase alpha and so on. And I'll not go too far into that because we're behind in this course, but our alphabet stolen pretty directly from the Greek alphabet. This is capital delta. Oh, by the way, here's lowercase delta, which you surely can sort of see our lowercase letter D in that. At any rate, when you see this symbol, this Greek letter delta, in math notation, it almost always is shorthand for the phrase change in, change in. So slope is the change in Y over the change in X. And so let's talk about what that means. By the way, I messed this up. I did it in this is the same sheet I used in the Monday night class for those of you who were here, and I messed it up then too. That is, I said that was the 0.13. It's actually the 0.12. I miscounted when I made the notes up and forgot to fix it. So, okay. Delta Y, change in Y. So remember, our Y-axis is the up and down vertical axis. X is our horizontal axis, the left and right axis. So it's the change in Y, which is the change in the vertical direction, or sometimes called the rise, over the change in the X direction, the horizontal direction, sometimes called the run, but I prefer to call it delta Y over delta X. Change in Y direction over change in X direction. Okay, so here's on our X axis and then on our Y axis. So here's what that means. Let's say that I start at this point where X is 1 and Y is 2. Let me zoom in on that a little bit. Let's say I start at this point where X is, maybe that's a little better. Okay, I'm going to zoom in. I want to look at this point where X is 1, Y is 2. And here's what I want to do. I want to move from this point 1, 2 until I arrive at this point 3, 5. And I want to do it as efficiently as I can, but here's my rule. I'm not allowed to move diagonally. I can only move horizontally and or vertically. So I guess I could do something like this. So everybody watch my pen. I could start here where X is 1 at this point 1, 2, and I could move to the right. I could move to the right, oops, until I'm directly under the 0.35, right? So that's a horizontal move. And then from there, and notice I went from where X is 1 to X, where X is 2, that's 1 unit that I moved to the right, on to where X is 3. So I moved 2 units horizontally to move from this point and get directly under the point I'm trying to get to. Everybody see that? Okay, now from there, I'm going to go vertically straight up until I hit that point, until I arrive at the point. So let's see what I did there. I moved vertically up from 2. I started at 2. I moved to 3. That's 1 unit. 4. That's 2 units. 5. I moved up 3 units. Everybody see that? So I got from the first point to the second one in 1 horizontal move and 1 vertical move. And the horizontal move was 2 units to the right. Remember, horizontally going to the right is positive and going to the left is negative. Vertically going up is positive and down is negative. So I moved 2 units to the right. That is my delta X. It's the change in my horizontal position, right? And then I went up vertically 3 units. That is my delta Y. It is my change in the Y or vertical direction. Everybody see that? Then the slope of this line, is delta Y 3 over delta X 2. So that line has a slope of 3 over 2, 3 halves. Everybody see that? Then what does that mean? Well, what it's saying is, the reason this is telling you how steep the line is because what it's saying is, if you're at any point on that line, if you go 2 units to the right and up 3 units, you're going to hit another point on the line, right? So, and of course, if you 3 over 2 is 1.5. So think of it this way. I don't write it this way. This is terrible form. But saying that going 2 units to the right and up 3 units would arrive at another point on the graph is the same as saying if you go 1 unit to the right and up 1.5 units, you'll hit another point on the graph, right? So in some sense, that's telling us how steep the line is. And for example, like if I was at this point, so let's look back up at the graph. If I was here, if I went, let's see if I can do it. and probably about 1, 2, probably about there. If I'm here, if I go, oh, I need to go up one more, probably be right there under the P. Sorry, I'm talking to myself. If I go 2 units to the right and up 3 units, I should hit another point on this line. So let's see what happens. I would go 2 units to the right. I'd be directly above 5 on the x-axis, and then 6, 7. I tried to squeeze that in there. Then if I go up 3 units, that would put me right about there. So I've gone from this point that we know is on the graph. I went 2 to the right and up 3. I can tell where that puts me. It takes me from where x is 3 up until x is 5. And it takes me from where y was 5. Remember, I went up 3, so it takes me where y is 8. Then the 0.58 is going to also be on that line. And does everybody see that? So slope, delta y over delta x. But here's what I want us to see. The 2 points that we graphed, 2 points that went through that line were the points 1, 2, and the point 3, 5. And so when we found our slope, we just moved, we had plotted those points and drawn the graph, the line that goes through them, and we plotted the points, and we just actually moved, you know, horizontally from the first point to right under the second. We counted how many units we moved. Then we counted up how many units we had to move till we got to that second point, and that gave us our delta x, which remember goes on bottom, 2, and our delta y, 3, that goes on top. So our slope is 3 over 2. Here's what I want you to see though. That delta y is 3. The y coordinates of our 2 points are 5 and 2. Y'all see that? Or I've got them written down here. I need to zoom back out. So the y coordinates of our points are 5 and 2. Or you look at them on the graph up here, 5 and 2. Do you see that if I had just subtracted my second y coordinate minus my first y coordinate, second y coordinate 5 minus first y coordinate 2, that would give me delta y, 3 units. Y'all see that? Similarly, my delta x was 2. If I had just subtracted those x coordinates, my second x coordinate is 3, my first one was 1. 3 minus 1 is 2, that's my delta x. So that's where this formula for slope comes from. So let me kind of get that on a cleaner piece of paper and we can talk about what this formula means. So slope is y2 minus y1 over x2 minus x1. Here's what this means. The subscripts here, like y1 and y2, technically that's y sub 1 and y sub 2. It's a subscript, but I just say y1, y2, x1, x2. What those are the x and y coordinates of 2 points on the line. So if I give you 2 ordered pairs and I say, find the slope of the line that passes through the points, maybe 10, -3, and I don't know, 6. How can I make that into something that's maybe 6, 5 or something like that? And I want you to find the slope of the line that passes through these 2 points. We could do what I did a minute ago. We could plot those 2 points, draw the line that goes through them, and then count how many units I have to move horizontally and vertically to get from one point to the other. But I think the best way to do it would be to say, look, this is my first point. I'm going to call 10 my x1, and I'm going to call -3 my y1. So x1 and y1 are the x and y coordinates of our first point that's on the line. And then I'm going to call 6 x2 and 5 y2. So x2 and y2 are just the x and y coordinates of a second point that we know the line passes through. Then I can find my delta y over delta x simply by using this formula. Just subtract the y coordinates on top and the x coordinates on bottom. So the slope would be y2 minus y1, 5 minus -3. Make sure y'all see what happened with the signs there. It's y2 minus y1. That's not 5 minus 3. It's 5 minus -3, right? And then x to over x2 minus x1. x2 is 6 minus x1 is 10. 5 minus -3 is really 5 plus 3, which is +8. 6 minus 10 is -4. We should always simplify our slope. 8 over -4 is -2, and that's the slope of the line that passes through these 2 points. Everybody see how to do this? You're literally just plugging the numbers into the formula. Thing to remember, be careful. I sometimes see students subtract the x's on top and the y's on bottom when they use this formula. That's wrong. We're supposed to subtract the y's on top and the x's on bottom. But do you see why somebody might make that mistake? Because if you're just trying to recall the formula from memory and you know that you're subtracting y's and you're subtracting x's, if you're not careful, you're likely to put x's on top and y's on bottom because x comes just before y in the alphabet, right? So think about how you learn stuff and make sure you learn it straight with the y's on top and x's on bottom. Then it really doesn't matter. Like, what if I did it this way? So let's say I've got this same problem, but what if I reversed all that? And what if I did, instead of y2 minus y1, 5 minus -3, what if I do y1 minus y2 on top, -3 minus 5? And instead of doing x2 minus x1, 6 minus 10, what if I did x1 minus x2, 10 minus 6? Would that make any difference at all? Nope. I'm going to get -8 over +4, but that's still -2. Do y'all see that? So it makes sense that it doesn't really matter which y coordinate you write first on top. But whichever y coordinate you put first on top, you have to have its corresponding x coordinate first on bottom. Everybody with me there? Okay, so once we see that, then we realize we don't need to, by the way, if I did graph this line, let's see, maybe I'll do it real quick. So 10, -3, and 6, 5. Y'all hang with me a second. I'm gonna see if I can do this. Maybe if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -1, 2, 3, 4, 5, 1, 2, 3, 5. Can't remember what the coordinates were. And okay, so 10, -3 would be about there. I just want y'all to, I'm just going to do a quick sketch. I want y'all to roughly see what the graph looks like. And the other one was 6, 5. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Somewhere right about there. So if I were to draw that line, something like that, right? Now there's our x and y axes. So that first one we looked at, what did I do with it? Lord only knows. Probably under here, maybe. Yeah. Okay, so this first one we looked at, notice the slope of this first one was +3/2. Oh, what happened there? Hang on. The first one is +3/2. Notice that line rises from left to right. Everybody see that? The slope of this line turned out to be, what was it, -2? I think it was -2. Notice how that line falls from left to right. So this turns out to always be true. Any line that rises from left to right has a positive slope. Any line that falls from left to right has a negative slope, okay? All right, so just real quickly, we'll do just in example or two here, finding slope, then we're going to kind of move on from that. So let's take a look at this one. We're going to do a quick, and I'm going to go through these real quick because we're getting close to break time. So we want to find the line, slope of the line that passes through these points. So look, let's just label them x1, y1, and x2, y2, and let's plug them into the formula. y2 minus y1, that's going to be negative 13 minus 2. x2 minus x1, watch your signs when some of these coordinates have negatives in front of them, right? x2 minus x1 is going to be 2 minus negative 3. 2 minus negative 3. And so that's negative 15 on top. But 2 minus negative 3 is really positive, 2 plus 3, and that's positive 5. Negative 15 divided by positive 5 is negative 3. That's the slope of that line. Super easy. Everybody see that? Another one quickly. 7, negative 1, and 4, negative 9. So y2 minus y1 is going to be negative 9 minus negative 1 over x2 minus x1 is going to be 4 minus 7. Negative 9 minus negative 1 is really negative 9 plus 1, which is negative 8, over 4 minus 7 is negative 3. So then the slope of that line, make sure y'all don't say the slope of the line is negative 8 over negative 3, because we want to simplify as much as we can. Negative divided by negative is positive. The slope of the line is 8/3. Everybody see? And of course, that's saying every time x goes up by 3, y goes up by 8, right? Here's a couple of special cases, and then we'll probably take our break. So when we find the slope here, so we've got our x1, y1, 2, and 3, and our x2 and y2, 4 and 3. So when I find the slope, y2 minus y1 is 3 minus 3 over x2 minus x1 is 4 minus 2. 3 minus 3 is 0 over 4 minus 2 is 2. Okay, somebody tell me, is this the one that's equal to 0 or is this the one that's undefined? 0? It's 0. Yeah, we talked about this at some length earlier in the semester. It's important to know this because it's going to matter on some of these slope questions. 0 divided by 2 is 0. It's not undefined. Undefined means there is no number represented by 0 over 2. There is a number. The number happens to be 0. It's when you're dividing by 0 that it's undefined, right? Like if it was 2 divided by 0, that would be undefined. So, okay, 0. So let's take a look at the graph of that. Let's plot those 2 points and see what the line looks like that goes through those. So 1, 2, 3, 4, 1, 2, 3. So, okay, x is 2, y is 3. That would be right about here. X is 4, y is 3. That would be right about here. So there's 2, 3. There's 4, 3. Do y'all see that the line that passes through those points is going to be a horizontal line? I know I'm drawing freehand, but that line is horizontal. Do y'all see that? So remember we said that when lines rise from left to right, they have positive slope. When lines fall from left to right, they have negative slope. Now we know that if we have a horizontal line, well, it's not rising from left to right, so it can't have a positive slope. It's not falling from left to right, it can't have a negative slope. In fact, just like 0 is the number that's between the positive and negative numbers, 0 is going to be the slope of every horizontal line, because that's what's between lines that rise and have positive slope and lines that fall and have negative slope. Does that make sense? And you can see that anytime if you have 2 points on a line that have the same y coordinate, that means every point on that line is going to have 3 as its y coordinate. Can y'all see that? Like here's 0, 3. There's negative 1, 3. There's positive 1, 3. There's 3, 3, and so on. So all horizontal lines have a slope of 0. One more kind of little different example. Let's find the slope of the line passing through these points. So we got our x1 and y1 and our x2 and our y2. You may already be seeing this. The last one we did, our y coordinates were the same, and we got a slope of 0, which indicated a horizontal line. Do y'all see in this case, it's the x coordinates that are the same? And so when I plug that into my slope formula, y2 minus y1 is going to be negative 2 minus 4 over x2 minus x1 is going to be 3 minus 3. And this time I'm going to get negative 6 divided by 3 minus 3 is 0. This is undefined, right? You can't divide by 0. There's no such number as negative 6 divided by 0. The slope is undefined. And that's all we can say about it. In other words, you can't assign a number to the slope of this line. That line, if we were to look at it, you probably already kind of have an idea what's coming here. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. So 3, 4, that point would be about here. And 3, negative 2, that point would be about here. And do y'all see that the graph of the line that passes through those points is going to be this vertical line that goes through 3 on the x-axis? Everybody see that? There's our point 3, 4. Here's our point 3, negative 2. And notice that's a vertical line. All vertical lines have undefined slope. If you think about it, that makes sense too, because as this line gets closer, y'all look, watch my pen, or maybe use the ruler. So pretend like this ruler represents my line. As the line gets steeper and steeper, right, the slope is positive. The slope's getting bigger and bigger as the line gets steeper and steeper. But what if, like once it's here, the line is super steep. It's still rising from left to right. It's still rising from left to right. It's super steep. The slope of that line might be 1,000,000 or something, right? Like x goes up by 1 and y goes way up by 1,000,000 or something like that. Well, when your numbers get bigger and bigger and bigger, they're going toward infinity, right? And infinity is not a number. You can't say this is the number infinity. And oh, by the way, once you get to the point where this slope is like 100 billion and 100 quadrillion or whatever, at some point you reach the tipping point and now the line's falling from left to right. And now you've got slopes of negative 100 billion or whatever and going down toward -1 or whatever. So the point is, when you find the slope of a line, every line that rises from left to right has a positive slope. Every line that falls from left to right has a negative slope. Every horizontal line has a slope of 0. Every vertical line's slope is undefined. Okay? All right, so at this point, we should be able to find the slope of a line. If we're given 2 points that represent, 2 ordered pairs that represent 2 points on a line, we should be able to use that formula to find the slope of that line. When we come back from break, we're going to talk about equations of lines. And so the idea there is, well, the first thing we're going to do is we're going to look at, if you have the equation of a line, how can you sketch its graph based on that equation? Then we're going to look at the opposite situation. What if instead of giving you the equation and asking you to sketch its graph, what if they give you information of about the graph and tell you to find the equation that would be the graph of? And so that's what we're going to do in the second half of class. Right now, we're going to take our break. It looks like it's 7:08, so let's just call it 7:10. So let's say about 7:20, we'll get started again. I'm going to